with our study of implicit differentiation, we've seen that we need to be able to find the derivative with respect to x of all terms. So it's probably worthwhile just go through a few of those that you should commit to memory. So the first one is that when we've got to find d dx of y, if we've got that situation, that's simply dy dx. Number two is when we've got derivatives with respect to x of y to some power. Let's just say it's y squared. The same thing applies if it's more. So to find that, where y is a function of x, we simply just find the derivative as if it's with respect to y. Now the derivative with respect to y is 2y. If it was y cubed, it would be 3y squared. So you find the derivative of that, and then you just write dy dx at the end. It's basically using the chain rule. So you go d dy times dy dx, there's dy dx. And you go derivative with respect to y. Derivative with respect to y of y squared is 2y. So that applies, as I said, no matter what the power of y is, you've just got to find the derivative as if you find the derivative with respect to y. Number three, and this is one that you should be able to do in your head, is that there is with respect to x of when you've got function of x here, we've got x, and then we've got y, which is also a function of x. So you've got two functions multiplied together, so we're going to use the product rule. If you like, this is my u, and this is my v, and we use the product rule. And the product rule says that it is u v dash plus u dash v. So we've got to be able to find them. U is simply x. V dash is the derivative of this with respect to x. So that's just using this rule up here. Derivative with respect to x of y is just dy dx. Plus u dash, the derivative with respect to x of x is 1. And then v is just y. Okay, so that's whenever you've got two functions multiplied together, but then we've got to just use the product rule. And lastly is if you've got a product. So these aren't so common, but the derivative with respect to x of x over y. So we're going to be using the quotient rule. Now once again, here is my u, here is my v, and the derivative with respect to x would be all over v squared. We start with v, u dash minus v dash u. So derivative with respect to x of x over y. Y is equal to v squared, so that'll be y squared. V is equal to y. U dash, derivative of x with respect to x is just 1, minus v dash. V dash is the derivative of y with respect to x, so that's dy dx. And u is just equal to x. Alright, so those ones you should be familiar with, at least be able to calculate them as we go and do more complicated examples with implicit differentiation.